We want to solve a question here, and I'm going to read it. It says, according to Ohm's law, we have I is equal to V over R. In other words, current is equal to voltage over resistance. If the voltage is increased from 10 to 12 volts, so we are increasing voltage from 10 to 12 voltage, volts, what should be the approximate change be in the resistance to ensure a drop of from 3 to 2 amps? So how do we deal with that kind of a problem? To deal with this kind of a problem, we got to take advantage of what we call partial derivatives. And in this case here, you can see that we are given that current is equal to voltage over resistance. And the thing we are being asked to calculate the change that will happen as a result of the changes in the other variables that we're given here, namely the voltage and the current. For us to get a change in resistance, the very first thing is to express this formula we express this formula such that resistance becomes the subject of the formula. So in other words, if we make resistance the subject of the formula, R will be given by V over I. And then it follows that for us to get the change in resistance, which I can denote with delta R, like that, delta R will be given by the partial derivative of R with respect to voltage times the change in voltage plus the partial derivative of R with respect to current times the change in current. So this is what we're going to use to find the change in resistance as a result of the change in voltage and current respectively. So now the question is, how do we find these derivatives? Partial R, partial V, and partial R, partial I. So from the formula, R is equal to V over I, we can differentiate with respect to voltage. And if we differentiate resistance with respect to voltage, what we are going to get there is 1 over I, and this is multiplied by the change in voltage, plus, now partial R, partial I, we are differentiating R with respect to current. So that becomes, if you differentiate there, you get minus V over I squared, like that, times the change in current. So now that we have the derivatives in place, the next thing would actually be to put in the values according to what the question has given us. So you'll find that the change in voltage, if you go voltage changed from, so the change in voltage will be equal to 12 minus 10, because the voltage changed from 10 to 12. So that means the voltage change there will be 2 volts. And the change in current, notice the current changed from 3 to 2. In other words, it dropped from 3 amps to 2 amps. So the change in current would be minus 1. So that's 2 minus 3, which gives us minus 1. So we can now go in and substitute these values into the derivative formulas that I have done here. So this becomes 1 over current. So current, we go for the original initial value for current, which was 3, because it changed from 3 to 2, times the change in voltage. We saw that the change in voltage is 2, plus minus V. What was the initial voltage? It was 10 over I squared current, that's 3 squared. So we have this like that times the change in current. The change in current here is minus 1. So now if we do the arithmetic here, we have that becomes 2 over 3, and that gives us a positive, so that would be 10 over 9. And if you add up these two things, 2 over 3 plus 10 over 9, and if we put the answer correct to 3 decimal places, that is going to be 1.778. And remember, what are we looking for? The change in resistance. So resistance is measured in ohms. So this would be ohms, like that. So we have calculated the change in resistance. So in a nutshell, we are saying here that if voltage is increased from 10 to 12 and current is reduced from 3 to 2, the resistance increases by 1.778 ohms. That's what this is saying. So that's how you to deal with such a question. And to deal with this question, like I said in the at the beginning, we take advantage of partial derivatives. So now I would kindly request you to subscribe to this channel, like and comment on this channel. Your comments will help us to answer more questions and put them on the channel for the empowerment of everyone. So let us comment, let us subscribe, and let us like the channel. Thank you.